Find the following antiderivatives. In this first example, we're trying to find the antiderivative of x to the fourth plus the square root of x. And I want to talk very quickly about this notation, this set of parentheses. Anytime that you have more than one term in an expression, you'll have to wrap parentheses around the expression. This happens so we can distribute the dx to both of these terms, so we can find the antiderivative of x to the fourth dx and the antiderivative of the square root of x dx. And since there's a plus sign in between them, that will be part of our final answer. And as it turns out, in this other example over here, we will be able to shorten this process of splitting this antiderivative into two different antiderivatives. In fact, there's a theorem about that states you can just find the antiderivative of each of these without having to write it out like this. So continuing, the antiderivative of x to the fourth, you'll add 1 to the power, and then you'll multiply that by the reciprocal of the new power. But over here with the x square root of x, this presents a problem as we do not have a power. So we need to rewrite this as the integral or the antiderivative of x to the 1/2 power dx. And so now we can find the antiderivative of x to the 1/2 power. So we still have 1/5 x to the 5th power. And to that we are still adding x to the 3/2 power. And then out front we're going to multiply by the reciprocal of that power. So 2/3. And don't forget the all-important plus c at the end. Now you might be thinking that back here from this antiderivative, there should have been a plus c in here. And for this antiderivative, there should have been another plus c here. So maybe we had this extra plus c in here. However, when you get a plus c from one term and another constant plus c from another term, you'll have two different constants. But if you add them together, you will just be left with one constant. So when you're going through and finding an antiderivative with more than one term, there will only ever be one constant. And this is your answer for the antiderivative of x to the fourth plus the square root of x. Over here in the next example, before I even try to find an antiderivative, I want to rewrite this as 1 over x to the 2/3 power. And then again, I'm going to write it as x to the negative 2/3 power. And that is so I can actually go through and find an antiderivative. And this time around, with this example, I will not be splitting it apart. We will just be going term by term to find the antiderivative. So first, I can take this first term, add 1 to the exponent to get x to the 1/3 power, and then I multiply the front of this by the reciprocal of the new power. The reciprocal of 1/3 is 3. And then from there, I'm going to subtract 4x, I'm going to add 1 to the power, 3, and then I'm going to multiply this entire term, but just this term, by 1/3. And then I need to have my all-important plus c. So the very last thing I want to do is to have 3x to the 1/3 power minus, I'm going to combine these two constants right here. 1/3 times 4 is 4/3 x to the third power plus c. And here's the antiderivative for 1 over x to the 2/3 power minus 4x squared.